Good evening, everyone, and welcome to the Vacuum Transport Seminar. This is our second session this semester, and the name of all the organizations. I'm very happy to welcome you tonight. Today we have a very interesting talk from the side of Eurotube, and in that sense, in a minute, I will hand over to Daniel for a profound introduction. And before that, I just quickly want to remind that we use the Slido tool, meaning we use the website slido.com, where you can pose all your questions. And after the presentation, we'll have a question round with the questions that have been asked on slido.com. I will put the details into the chat. We're over to the talk, and I would like to hand over to Daniel for a short introduction. Thank you very much.
Thank you, Natalie. Thank you, everybody, for joining today's session. Today I have the pleasure to welcome a good colleague of mine, Nuan, who is currently working at Eurotube as a mobility engineer since already almost 1 year. Nuan, she has a background in transport planning and management at the university from Beijing, where she successfully conducted these studies, and then the motivation for getting into know more about the mobility sector brought her to Switzerland, where she did her PhD as a transport system engineer on the topic of role of information to passengers in public transport disruptions. The thing is, this doesn't end there. After her PhD, she conducted a postdoc research work together with SPB, where she studied a framework coupling passenger demand while considering the actual demand of the trains. In today's talk, she will be presenting us the vision on vacuum transport on a European level and how this will impact our way of moving in a, let's hope, short future around Europe. So without any further dilation, I leave the floor to you, Nuan. Thank you very much for joining us, and we're glad to hear your presentation.
Yeah, thanks a lot, Daniel, for the great introduction. Then perhaps I would go strictly to my presentation. So today the topic I would like to share with you is long-term passenger prediction of vacuum transport in a European network. So the topic, following this topic, I would like to separate my talk to 3 parts. First, I would like to give you an impression about the accessibility with vacuum transport to show how the convenience that vacuum transport could bring to the passengers. And then the second part are the main topic of today, trying to show you about the passenger prediction, including the approach and also the results. And then I would open the floor for discussion, and also I would like to introduce you about the outlook of my work. So first, you could see from these 2 plots about the accessibility without transport and with transport. So on the left-hand side, I plotted what is the accessibility to the city of Zurich with the current public transport, which are already very well developed. So you could see that basically, if I divided all of the time slots based on the 90 minutes, you could see basically only the regions around Zurich and also around a bit center of Bern could reach to the Zurich city within 1.5 hours. It's already very convenient, but I just want to show you what would it bring with the vacuum transport in the future. So as I show on the right-hand side, so if we build up a Hyperloop with the line from Geneva with a stop at Lausanne, Bern, and then reaching to Zurich, you could see if with this Hyperloop network, then the city from Geneva and a big region around Lausanne and also a big region from Bern actually the passengers from this region, it could have a very good accessibility to Zurich within 1.5 hours. So with this plot, you could see that actually with the faster accessibility to a neighbor city, actually passenger perhaps changing their behavior, for example, living in one city and then working in another city and then commute in between within 1 day. So with this impression, then we could go to this, the main topic of today about the passenger prediction. So you could see I extend a bit the research scope from only the Switzerland network into a whole European network, where I included 11 cities in my research. And from here, I mainly want to understand what would be the passenger flow for vacuum transport in the future with the competition of other two transport modes, that's the aviation and the railway. So to get these numbers, for sure, I need to base on some research methodology, which based on a big data set of the historical data, including the transport-wise about flight and railway, and also including the demographic and economic data, and also including the geopositioning data. So for the approach side, for sure, I did a lot of data analysis about the historical data, and based on this, use the widely used prediction model, which is called the 4 steps, to predict for the newly built transport system. So this model here, I mainly used these 4 steps: trip generation, trip attraction, trip distribution, and also mode choice. So from the output of the prediction, you could see the passenger flow for the different transport systems. And here I would like to show you some main results from this research. So first, you could see that I show you the passenger numbers depending on the years. So as you could see, the green line shows the historical data, which is what I collected of the real data so far. And then, as you all know, there is a drop of the passenger flow due to the COVID. But then here we just assume that COVID could recover soon. And as we see now, yes, it would recover soon. And for our prediction, we said in 3 to 4 years, the COVID passenger flow for the whole transport system could recover back to what we have on 2019. And then you see for the prediction, I have 2 lines. One is the yellow line, which showing that if we don't have the vacuum transport system, you could see in the future, the whole demand for the transport system would increase in a kind of linear growth. But if we build up the vacuum transport system, here I assume that we would start to building up the first line at 2030. And then by years and years, with the growth of the transport system of Hyperloop, then you could see that in the future, we would have quite a big increase about the demand with the vacuum transport system. So for the total amount, I would say that if without the vacuum transport system, the total passenger demand would increase around 40% of what we have in current years until 2050. But if with the vacuum transport system, the total demand could be a kind of double of what we have currently. And then the next plot you could see, I would like to show you more details about each passenger OD. Here, I only show you the results about the mode share. So from the plot, you could see that the blue color shows the mode share of vacuum transport, and the yellow shows the flights, and then the green one shows the railway system. So you could see that for most of the ODs, the mode share of the vacuum transport is around 60%, which is quite large. In comparison, you could see the market share of flight could reduce to around 30%. And then for most of the routes, the rail system can only share a very low market. So for sure, I need to do a great interpretation of these results. So in my settings, basically the lower mode share for the flights is mainly due to its longer waiting time. So that means for the current flight system, normally passengers need to arrive the airports from their home in advance, even like advance around 2 hours, around 1 to 2 hours. But we assume that vacuum transport is have a much better accessibility compared to the flights. And then with the two comparable speed of these two transport modes, so for sure the vacuum transport overall passenger would take a lower journey time. And the reason for the lower market share of the railway system are mainly because of the lower running speed on the way. So that means passenger would take a much longer time on their journey compared to the flights or vacuum transport system. So for the conclusion part, I emphasized some numbers for you to remember or to share it with others. So I repeat the results from the total passenger flows. Basically, I would say if we could build up a decent vacuum transport network throughout the European level, actually in the future, it could help the passenger flow get a quite a great increase, around 50% more until 2050. And then for the different ODs, actually, from the result, we could see that the vacuum transport would take a much larger market share, especially for the long distance parts. For example, Basel to Amsterdam, we could see that vacuum transport could conquer around 70% of the whole market. But if for the very short distance, for example, Zurich to Basel, the vacuum transport could only take up around 50% of the market. That's because even though currently the railway system between Zurich and Basel, you would only take around 1 hour. So in this kind of saying means the current railway system already very convenient between this short distance. And then overall, you could see that for the three transport modes, basically the mode share for the vacuum transport would be around 3 to 6 times larger than, the flight system would be around 3 to 6 times larger than the railway market share. And the vacuum transport could take up around 3 times larger than the flight and even flight and railway. So for the discussion round, actually, I would like to ask your opinion about my prediction results, and also what other aspects you would like to understand more, and for the prediction parts. From my own side, actually, I see this kind of research could have a lot of more directions for the extension. For example, one thing is I could try to expand the network, not only including 11 nodes on the network, instead perhaps a more dense network throughout Europe could be considered. And then I'm thinking try to gain more data. For example, including also the competition to the road traffic, or even because currently the competition between the three modes are mainly depending on the accessibility. For example, the ticket price will also include affects a lot about the passenger flow, which can be also included. And then based on the demand prediction, for sure, we could try to understand how to do the route planning throughout this network. And also in a more extendable wise, here in this prediction, I only focus on the demand side, like the pure passenger demand based on the features of different modes. And what happened if we include about the supply parts. For example, the current railway system has a larger capacity compared to aviation system. And if the vacuum transport could not support so such a big amount of passenger, what would happen? So we could do more iteratively understanding between the supply and the demand simulation. And for example, the results for sure, it's very helpful to understand more about the features of the vacuum transport. For example, the economic and the ecological life cycle for the vacuum transport. And even in the future, the research could be more extendable to understand for the passenger flows within a station or even within a vacuum transport ports. So I see this research could link to many other research, and it's a very good outlook to see how it could be extendable in the future. So thanks a lot for your attention. And here I would like to open the floor for discussion.
Thank you very much, Nuan, for the nice presentation. I think looking at the questions listed, we'll be having an interesting conversation. So just to start from the list, the audience was asking how long would the shortest trip be? Because it means trains have less than 5-minute stops.
Sorry, could you repeat a bit the question?
So someone from the audience is asking how much the shortest trip would go, because the trains have stops under 5 minutes.
Yes, so I could not say a very detailed number now. If I'm not wrong, from Zurich here to Basel, the minutes is around for sure within 10 minutes, and it's around 6 minutes, I would say. Current railway system is around 1 hour for this trip, so it can be the shortest part of my research. And basically, all of these calculations are just based on the assumption of the Hyperloop system. The running speed is 900 kilometers per hour. Yeah.
Okay. Great. Thanks for the answer. Then we have another question from the audience. Someone is asking which assumption in your model leads to this share of 60% of vacuum transportation? Isn't it too optimistic?
Yes, so that's what I also mentioned, which can be extended more in the future. So basically, these prediction results are mainly based on the travel time of the three transport modes. So I say it more specifically, the flights and the vacuum transport has a relatively high running speed, around 900 kilometers per hour. And the railway system, I did a calculation with the average running speed of the current railway system. And then, so the travel time, what I calculated, I call it general travel time. It's not only including the en route journey time and also including the waiting time at the airports. So the vacuum transport and the railway system, I only included a few minutes of waiting time at the station. And then flights, I involved around 2 hours waiting time at the airport. So basically, for example, the flights from Zurich to Frankfurt, the flights are only 1 hour on the journey, involving the waiting time. So overall, if you take a flight, it needs 3 hours. But for the vacuum transport, it would be just a bit more than 1 hour. So with this comparison, you could see that for sure, a lot of passengers would choose vacuum transport. So I think that the audience who would like to ask this question, he also want to understand perhaps there are more factors for this calculation. So I would say if we include about ticket price, for example, it may also change the behaviors of the passengers. So the current results are mainly based on the general travel time, as I explained. Yeah.
So overall, we would be reducing by 1/3 the time compared to two planes.
Yes, sir. Yes, sir. And it's also because of the network I'm studying. It's the European network, and as you see between all of the nodes, the on-journey time of flights are not too long. But if we consider, like for example, like the over-continental flights from European to America, no, Hyperloop cannot reach from European to the East Asia. Then the Hyperloop, I mean, if the on-journey time is large enough, then the waiting time, the drawback of waiting time from flights could reduce. That's what, yeah.
Great, thanks for the detailed explanation. Then there is another question regarding tunneling. So how does the impact of tunneling influence the decision-making of European routes? What is the overall impact on the construction? Have you looked into this as well?
Yeah, okay. Thanks for this question. So for today's presentation, we didn't include this part yet, but we are already on the next step of this route planning of the European network. So in this case, for sure, the construction cost or even the maintenance or operation cost will affect the results. Yeah, so currently I could still not give you very detailed instruction of this part, but I would say, so for our current research, we already try to involve this factor for understanding the passengers. Yeah. Yeah.
Great. Then there is another question from the audience, and it's regarding the domestic travels here in Switzerland. So the question is this applicable model for domestic travel in Switzerland, or is Switzerland too small for that?
Sorry, what is this question? It means he would like to understand more about this domestic graph, or?
Yes, exactly. I think the question is more regarding if the model you implemented is only for domestic travels in Switzerland, or is Switzerland too small for that?
No, I mean, here, actually, I just want to show the accessibility to No, I think it's not because of Switzerland is too small. It's more like what's the focus of the research. So for example, for the Swiss case here, I just compared the results between public transport and also with the vacuum transport. And for sure, for the understanding of the demand within Switzerland, we could also consider about the convenience of the private mode. For example, taking the car, how much we could increase about the travel time. And later on, what I introduced here is just we want to understand more about the competition among vacuum transport and aviation, and also include about the long distance railway system. So it's not because of Switzerland is too small to understand the results. It's more about the research scope, I would say. Yeah.
Then there is another question, which is, what is, in your opinion, the most probable route in Europe which will be established first?
Okay, very great question, because we just had some preliminary results currently. So we had the results already showing that, so what that research question is, what would be the route planning procedure following the budget limitations. So we could see that if we have a very low budget, probably the first line, I mean, throughout my current network, I didn't include in more nodes to understand the network. So only following these nodes, basically the first route would between London to Amsterdam, because currently for the prediction, they too have the largest passenger flow. But I also get some very interesting results shows that if we could extend more about the budgets, actually it would suggest to build up the vacuum transport first from London to Paris and Paris to Amsterdam, instead of build up a direct line between London and Amsterdam. It's also because of the position of Paris, it could have better links to other nodes. So that means we could use a lower budget, try to link more nodes and serve more passengers. So from this result, you could see that depending on the different budget limitations, it has some priorities to build up the routes. Yeah.
So this would be meaning closing the first commercial route overseas between London.
Yes, that's also the great question, because what the results I said, it's also I based on the cost, the construction cost only depending on the kilometer instead of the real condition. As you said, for sure over the sea and even like here over the Alpines, it may cost the other routes. Then that's also I want to extend a bit that part of my research. Yeah, for sure.
Great, great.
Yeah, and I repeat, so today what I discuss here are mainly from the demand side. So only from the numbers of the passengers, and it can be more detailed to extend the research. Yeah.
This question is really linked to the next one. Someone is asking that if you didn't include the ticket price in your calculations, are there more assumptions that you made in order to get to this data?
To get the data of the ticket?
Yes, exactly, because I think the price of the ticket hasn't been taken into consideration.
Yes, sure. It's not like how to say. So the tickets data are not very well recorded. I would say there are not a very good open data source to record the tickets for each day, and if we need to get the data from the specific either airport or railway system, so it still takes a bit of efforts to get this. Yes.
And then the final question, someone from the audience is asking, which software tool do you use for your simulations or to work with on a daily basis for your studies, for your research?
So yeah, currently I didn't use the open software, open source software. I mainly write all of the data, all of the logic or code or model by myself. Yeah. Yeah, so it's a kind of a platform built up from zero, and as I introduced, we would like to extend it quite a lot. Yeah.
Thank you very much. I think then those have been the questions so far. Natalie, if we want to do the closing, I think for today we are done.
Yes. So again from all our sides, thank you very much, Wan, for your presentation and your insight into your research work. It was very insightful. Thank you very much for your contribution to the seminar.
Thanks a lot for giving me this opportunity. And I also, it's a very good chance for me to understand the interest of the audience. I think that would be the main directions to extending our research for sure. And thank you again, Natalia, for offering me this opportunity. And also Daniel, thanks a lot.
Thank you very much. Thank you very much. And also thank you to the audience who participated, and of course to the other organizers for all your work and contribution. And so in that sense, we would like to close today's seminar session. We will see each other again in a week for our next seminar. Again, the same time, the same place, so the same Zoom link. As you might have seen, we also advertise, like already last semester, we advertise also on LinkedIn. So if you would like to contribute or to support, please feel free to hit the participate button on our LinkedIn advertisement. That will be a good contribution for our seminar also. Yes, so in that sense, we wish you a great week, and we see you again in a week, next week, for our next session. Thank you very much to everyone, and have a great evening, and see you soon. Bye, everyone.
Ciao.
Thank you. Bye-bye.
Have a nice evening.
Thank you. Bye-bye.